This is a homework helper for Chapter 12, Section 7 in the 8th grade workbook, Solving Systems of Linear Equations by Graphing. Alright, let's go ahead and start off with number 1 and 2. In 1 and 2 here, we're asked to solve the system by graphing and then check our answer. As far as checking our answer, what that means is once we find the values for x and y, we're going to plug those back into each equation and make sure the left side equals the right side. Not going to spend so much time focusing on that as we will actually solving the system. Remember, when we're talking about solving the system, what we're doing is we're graphing each equation, and then when we graph the equation, both equations, we're going to find the point at which the two graphs intersect. Because the point at which the two graphs intersect is the one point that I can plug in for both equations and make that left side equal the right side. On each line for each equation, there'll be a whole bunch of points that work. But there's only one point at which I have that intersection that works in both equations. And again, that point of intersection happens to be our answers here. So let's look at number 1. Y equals -1 and y equals 2x minus 7. So this first one here is one we really haven't seen a whole lot. Y equals -1. That's asking you to graph a line where the y value always equals -1. So let's start off here. Where is y -1? Y is -1 right here. So I want to graph a line where it's going to show the y value, no matter what point I'm at, is equal to -1. Well, that's simply a line that goes from left to right through -1. Because no matter where it is on that spectrum, the y value of the coordinate is always -1. Whether I'm here at 2 -1, or 6 -1, or -5 -1, the y value is always -1. Then y equals 2x minus 7. All right, I look at what's at the end here. It says -7. All right, this is in slope-intercept form, so that's why I'm looking what's at the end here. -7 means on the y-axis, I'm going to put a dot at -7. And then the slope here says 2, as in 2 over 1. So that means I'm going to rise 2 and run 1. So from this point, go up 2 and right 1. Repeat. Go up another 2, right another 1. Repeat. Go up 2, go right another 1. And as you can see, I'm going to stop because now I have a point of intersection. That point of intersection, that coordinate, is the point at which the left side will make the right side of the equation equal out. At 3, -1, these two lines intersect. And so that's the solution to the system of equations. When I change x into 3 and y into -1, these two equations end up equaling out. All right, let's go ahead and take a look at number 4. Question number 4 says y equals 4x minus 3 and 2y minus 3x equals -4. All right, so that first equation is written beautifully in slope-intercept form, so we're going to go ahead and graph that using the techniques of slope-intercept form. Slope-intercept form tells me I look at that value at the end first, which says -3. So the y-axis point here is going to be -3. Then I come and look at what's in front of x here, and that's my slope. My slope here says 4, as in 4 over 1. So from this point, I'm going to go 1, 2, 3, 4 up, 1 over. Repeat. 1, 2, 3, 4 up, 1 over. Repeat. 1, 2, 3, 4 up, 1 over. I'm off the graph, but there you go. All right, now the second equation, you've got choices there. You can either A, manipulate the equation, or B, graph this using the intercepts method. It doesn't really matter which one you do, as long as you do it correctly. If we want to manipulate the equation to make it look like this, what we're going to do is take that equation and move the 3x part to the other side. I'm going to do that by adding 3x to both sides. So it's going to give me 2y equals 3x minus 4. Now, that's not bad. But the problem is I got this 2 in front of the y. And to be in slope-intercept form, I'm going to have to go ahead and divide across by 2 here. When I do that, I get y equals 3/2 x minus 2. And that's in slope-intercept form, which we could then graph. if you wanted to go with the intercepts method, recall using the intercepts method, first time through we let x equal 0, find the y value. Other way through, we're going to let y equal 0 and find the x value. Whatever the x value is where I'm going to put a dot on the x-axis. Whatever the y value ends up being is where my dot goes on the y-axis, and then I connect my points. Either way, whether I travel down this path or this path, the graph of the system will be, or the graph of the equation rather, will be the same. It's just a matter of preference. I really tend to like slope-intercept form, and since we already did the work that's involved here, I'm going to go ahead and graph this. I'm going to go ahead and change colors. The end of that one says -2. So I'm going to go ahead and go down to -2 and put a dot. And the slope here says 3/2, which means I'm going to go up 3, right 2. I go up another 3, and right another 2. And as you can see, we're going to have an issue here because the point of intersection actually is going to happen down here. You can see this line is going like this, and the line that we started with, which I did in black there, is going something like that. So, point of intersection here actually